Hello everyone. Have you ever been worried about the radiation producing radio waves that your cell phone emits? Wonderful, because today we're going to be simulating those radio waves inside of Unity, so that way no matter where you go, you can induce yourself with as much radio waves as you want.
Wow!
So before we even get started, I should probably learn what a radio wave actually is. So we'll just go on to Google here, take a look at the images, and yeah, so it looks like a radio wave is actually a wave that transmits radios. That's perfect. It shouldn't be too difficult to replicate, so let's go ahead and start programming. Unfortunately, real radios have to deal with this pesky problem of signal to noise, where as soon as a signal is transmitted, it starts to pick up interference. Eventually, that interference becomes so great that you can't figure out what your original signal was. This means that we can't just blend between two signals inside of Unity. It may be easier, but it doesn't mean it's better. So instead we're going to have to go online, find a way to read the audio samples from a Unity file, import that into our Unity project, and then use that to figure out what the actual difference is between our signal and noise so that we can actually separate it. Anyways, here's what that sounds like. To figure out the problem, I made some graphs and found that the signal was way too erratic. So after some short research on smoothing out data, I implemented a moving average filter which solves the problem. This does, however, raise another problem. Whenever an audio file has quiet moments in it, the static ends up coming through even whenever the signal strength is relatively high.
About the little beggar whose mother died a long time ago. Son, be quiet and listen. Now you were asleep.
We can easily fix this by weighting the volume of the signal towards 1 whenever the signal strength is high, and then using the blended volume whenever the signal strength is low.
That they would always bring me bread. No, I had no mother, mister. Yes, she left a long time ago. Do I have a dad, you ask me? Well, now, mister, I don't know.
Hey, that's pretty good.
The easiest way to implement this would be to set a max distance for the transmitter and just divide the distance between the receiver and the transmitter by that maximum distance. But we're no scrubs, so we're going to do it the right way and use some actual math to figure out the distances. The three main elements that affect the max detectable distance of a signal are the power of the transmitter, the types of antennas used, and the sensitivity of the receiver. So we can just find some nice people online who already figured out the physical equations and implement their algorithms with a little bit of math. With the algorithm implemented, we can actually spend time creating a visualization to see how it actually works that I definitely didn't hit my head against the wall for. Now all we have to do is just implement that into our calculations for the actual signal strength, and we have something that kind of works.
Mother told me before she left me Dad might come for me. I guess he come when I was going.
All we need to do physical abstractions is the location of the transmitter, the location of the receiver, how many walls are in between them, and Unity's physics raycast system. With that, we now have a rough simulation of physical obstructions for the signal. Everything in the project is being handled by scriptable objects, so thankfully it's relatively easy for us to just read the data from those objects and show the player the information that they need to see. It also reduces script references, which means that we'll have less errors in general while implementing new objects. Basically what I'm saying is if you're not using scriptable objects, you should be!
I was up there with 3 Russian cosmonauts. That's actually...
Your mother, mister. Yes, she left a long time ago. Do I have a dad, you ask me? I don't know.
Vintage radios are cool, but let's make a real radio. We'll need a first-person script, a model of a hand-told radio, a radio tower, and some environment assets. After preparing the ingredients, let it simmer in the pot for 1 hour, then take it off the heat. Once you're done, you'll have a well-cooked example scene to show off your work.